Okay. Again, you have some rules, like the way we have rules for differentiation. We also have some for integration, which will help you to solve the integration problem quickly. Okay, so the first rule is kind of straightforward, and it's just going to follow from the rule of the similar rule for the derivatives. Okay, so I'm not going to prove it. You can try proving it yourself. Okay, it's just straightforward. Okay, so integral of a fx dx, where a is a constant, is actually a times integral fx dx. Okay, is that fine? Okay, it's just very, very straightforward. Similarly, integral of the sum of the function is the sum of the integrals. Okay, it's just going to follow from the fact that the derivative of the sum is the sum of the derivatives. Okay, you can do that. Okay, and check that it is indeed the case. By the way, there is also a name, another name for indefinite integral. You also call it sometimes antiderivative. Okay, just in case if you come across this term, it's the same thing. Okay. Okay, so let me give you two more rules, which are very useful in finding integral, solving integral problems. So one is integration by parts, okay, and the other is, integration by substitution method, okay, and both are kind of very, very useful. So let me tell you those two techniques, okay. So one is integration by parts, okay. So again, you don't have to remember this formula, okay. It's actually very easy to derive. So if you know the product rule for the derivatives, then it is actually straightforward, from the product rule of derivatives. Okay, I mean this particular expression. So what I'll do is I'll quickly tell you how to derive this. Okay, and then we'll do one application so that you know how to use it. Okay, fine. Okay, so can you tell me what is the derivative of fx dx? What is the product rule? Right? Yes. Okay, now let me do the integration. Let me just integrate both sides. Okay, now do you agree if I'm going to integrate the left hand side, because derivative and integral will undo each other? Okay, so I'll be left with just this term, and on the right hand side I'll have these two integrals. Do you agree? Yes, because integral of the sum is the sum of the integrals. So left hand side is this, left hand side is equal to the sum of these two right hand sides. Yes or no? These two terms on the right hand side, yes or no? Okay, now can you see this is just the rearrangement of this term? Just take it to the other side. Integral fx g prime x dx is equal to fx gx minus integral f prime x gx dx. Okay, so in case you forget this formula, you can quickly write the product rule for the derivative and then derive it. Okay, just one step. Okay, that's it. And then once you know this, now you can use this to solve very many integration problems, okay, involving finding the integral of the product of two functions. Okay, is that fine? Okay, so let's do one application. Okay, so let's find the integral of x e to the power minus x dx. Okay, so we have two functions involved here. Okay, and we want to find the integral of this particular function, indefinite integral of this particular function. Okay, so let's do it. So I'm just going to straight away use this formula. Okay, so well, there is some rule of thumb, like which function to take as first function, which function to take as second function. So it's I late, right? So you can use that. Okay, so the first function is this one, and the second function basically, this fx is x, okay, because that's an algebraic function, so that's going to come before the exponential function. So I'm going to take that as my first function, okay, and g prime x is e to the power minus x, right? Okay, so now I have exactly in this form. Do you agree? The left hand side is exactly in this form. Do you agree? Yes or no? Okay, now I can use this formula. Okay, so what do you think should be fx? Well, fx is already x. What do you think should be gx? If g prime x is e to the power minus x, what is gx? No. Yeah, so it is minus e to the power minus x, right? So if you have trouble with this minus sign, always take the derivative and check. Now once you have gx, now I think we are done, you know, most of it. Okay, so if you see, what is fx times gx? Okay, and what is f prime? Now that's basically the key thing, you know, why we took x first and not e to the power minus x. Okay, now notice that when you take the derivative of x, it becomes 1. But if you take the derivative of e to the power minus x, it stays as it is. So, you know, you want to reduce this product so that you can easily solve it, right? Okay, you want to remove one term, right? Okay, so I mean, it's best if you take the first function as algebraic function rather than e to the power minus x, because e to the power minus x will never vanish no matter how many times you differentiate it. Okay, but x will vanish with one derivative. Yes or no? So I mean, sometimes you might want to keep these things in mind, so that also this will also help you to figure out what function should be first and what should be second. Okay, so anyways, so integral of e to the power, so what is gx? Gx is this, right? Minus e to the power minus x dx, right? Can I write like this? Yes. Okay, now what is this? Basically minus x e to the power minus x plus integral e to the power minus x dx. And what is integral of e to the power minus x dx? Minus e to the power minus x. So you're going to get minus x e to the power minus x minus e to the power minus x, and then just add a constant. Yeah. Is that clear? That's basically the indefinite integral of this term. Again, if you want to check, what should you do? If you got this right or not? Yeah, take the derivative. Right? take the derivative of this and see if you're getting this or not. Okay, I'm just quick check.